Hello everyone, my name is Koma Signolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, hello. We are going to continue our lessons on functions in this video, and in this video hopefully it'll be a short one. I just want to focus on function notation. Okay, what do I mean by function notation? It's simply the way in which information for functions can be given mathematically using mathematical notation or mathematical symbols. Okay, it's simply how transformations for functions can be expressed, or manipulations for functions can be expressed. Okay, so we know that firstly, a function can be called any letter, right? A function can be called f. This is the most popular letter that is used. F. It can be called g. It can be called h. It can be called anything, right? This is the name of the function. So the letter is just the name of the function. Name of function, and we described what a function is in the very first video on functions. Okay, so f, g, and h can be the name of a function, right? And then as soon as you do something like this, now you can have f of x. What does f of x mean? Well, f of x simply means that you've got a function called f, right? Function called f. The function is called f, and it is made up of x's, right? It is made up of x's, or the variable x, made up of x, right? It can be f, it can be g, it can be h. Like I said, it can be any letter. These are the three most popular letters that are used in functions. Okay, so the name of the function is f, but then that f is made up of x's. Okay, so an example of that would be f of x is equal to x squared plus 2x plus 4, whatever. Okay, x squared plus 2x plus 4. Okay, this is a function and it is made up of x's. The name of the function is f, and it is made up of x's, and these are the x's that make it up. These are the x's that make it up. Okay, same thing can be said for h and g. If you've got g of x, well, this is a function called g made up of x's. For example, you can have x plus 2, right? This is just a description of the function called g. That is the description of a function called g, which is made up of x's. That's simply it. Okay, so another example, let's say you've got h of b. H of b, right? This tells you that this is a function called h made up of b's. Okay, this is a function called h made up of b, so you could have b to the power of 3 minus b plus 2. Okay, this is a description of a function called h that is made up of b's. Okay, so that is what that means. Now, what about the manipulations that can be made, or the transformations that I was talking about? Okay, so let's say you've got f, a function called f made up of x's, and that function is given by x squared minus 4, right? It's given by x squared minus 4. That is the description of a function called f made up of x. Okay, let us firstly, let's just sketch that. Okay, let's just sketch that very quickly. You will agree with me that this is a parabola, and you will agree with me that the intercepts are at 2 and minus 2. So that's minus 2. The x-intercepts are at 2 and minus 2, and the y-intercept is at minus 4. At minus 4, and you will agree with me that this graph is a parabolic graph that looks like that. Okay, you should have a look at the video that I made for parabolas if you don't know where I got this from. Now, this is the graph of f, right? This is the graph of f. This graph is the graph of f. So the name of this graph is f, and the way this graph is shaped and the way this graph behaves is given by that there. It's given by that there. Okay, the description of the function. Okay, so that is the function called f. Now, what if I wanted to manipulate this graph using some notation? Okay, using some notation. This is the point of this video. This is the point of making this video, about function notation, so that you can understand the different ways in which the manipulations of the functions can be presented or represented mathematically. Now, let's say you've got that graph, right? You've got f of x. Remember, graph is called f, made up of x's, and the equation of the graph is x squared minus 4. It's x squared minus 4. Right. Now, what if I said to you, what does minus f of x look like? What does minus f of x look like? What is this saying to you? What is this saying to you? Well, this is saying to you, I want you to take f of x. I want you to take f of x, and I want you to multiply everything that f of x is made up of by a negative. Okay, so you will notice that you've got f of x here, and I want you to multiply everything that f of x is made up of with a negative. What is f of x made up of? F of x is made up of x squared minus 4. Here's f of x here. Here's what it is made up of, right? It is made up of that expression there. So you will take a negative, you will take that negative, and you will multiply everything that makes up f of x, which is x squared minus 4. Okay, and then you will solve. So you'll have negative times x squared is negative x squared, and then you'll have negative plus 4, that's plus 4. And then this will be your f of x. This will be your minus f of x. Okay, easy. It simply means multiply f of x by a negative, multiply everything that f of x is made up of by a negative. Okay, let's show you another example. Let's say now you still got f of x. You still got f of x is equal to x squared minus 4. Now let's say I say to you, I want you to multiply, give me the value for a f of x. Give me the value for a f of x. What do? Well, you know what f of x is. F of x is given by x squared minus 4. All you do is you take everything that makes up f of x and you multiply it by a. Okay, that's all that this means. It's simple things. So you've got a f of x is equal to a times everything that makes up a f of x. Okay, you can stop here if you want, or you can simplify it further, where you have a x squared. You've got, just move this down a bit. You've got a x squared minus 4a. Okay, and then this is going to be your answer. Okay, similarly, say you're being asked, you've got f of x. I'm going to use this for all the examples that I'm going to present because it's simple. You've got then minus 4. Oh, by the way, I sketched that graph up there, right? I sketched that graph up there. Now you can see that for the first example that I gave you, where you multiplied f of x with a negative, you got a completely different equation. There's your equation that you got there. So then when you sketch this, it's going to be different. It's going to be different from the graph that you sketched. Okay, here's the graph that you sketched there, and we know that this graph is called f. Now that graph that I multiplied by negative will go in the opposite direction to that graph, so it's gonna do that. It's going to be identical, but it's going to travel in the opposite direction. Okay, this is the graph of minus f of x. Okay, this is minus f of x. Sorry, this is this is the graph of minus f of x, but its name is minus f. The name of the blue graph is minus f, and that is the graph that we found down here. Okay, that is this graph that we found down here. Okay, so that's just to illustrate that graphically. Okay, now let's say they ask you to find f of x plus a. F of x plus a. Well, what they're telling you is that take f of x, take everything that makes up f of x, and add a onto it. Okay, take the expression of f of x and add a onto that expression. What is the expression for f of x? Well, we know that f of x is equal to that x squared minus 4. So all you've got to do to get your answer is say f of x plus a is equal to x squared minus 4 plus a, and that is your answer. Easy. Okay, so what if they ask you to give them x plus a, f of x plus a? You will notice that the a is inside the bracket. So what does it mean? Remember earlier on when I started this video, I said what is inside the bracket is what the expression is made up of. Okay, this is what the expression is made up of. So in this case, the expression is made up of not only just x, but it's made up of x plus a. The expression is made up of x plus a, right? Okay, so remember what f of x is. F of x is this is the f of x that I'm using as an example. You will use the f of x that you are given in the question that you will be addressing at the time to do such operations. So if I ask you to find, if this is f of x, I give you f of x, right? And I say to you, find f of x plus a. How will you tackle this? Well, you will say f of x plus a is equal to, now remember I said this is f, the function is called f, and it is made up of x plus a. So wherever you see a variable, you will substitute x plus a. So where's our variable here? Our variable is x, right? In our original function, our variable is x. So wherever you see x, you will put in x plus a. Okay, so firstly, I'm going to open a bracket. So instead of just x, I'm going to put in x plus a. And it's always easier to substitute these things in brackets. Okay, even if you don't need brackets in some instances, just always use brackets. It groups things nicely. Then I've got squared. That's that squared there. Okay, so notice that where I have x, I've got x plus a. Okay, I keep everything else the same. So the squared is there, the squared is here, then minus 4. Okay, and this is what I will get. Okay, you can simplify it further, or you can make it more complex. Actually, it's simple as it is already, but you can make it a bit more complex by multiplying things out and leaving it in one of the other standard forms. But this is far enough. Okay, gets the point across. Now, what if I still give you the same x, f of x, okay, and then I say to you, actually, let me not use f. Just to drive the point home, let's say I give you g of x, and I say g of x is equal to x plus 2, right? And I say to you, what is g x minus 3? How will you get that? Well, my graph is called g, and it is made up of x minus 3. Okay, it is made up of x minus 3. So wherever I have x, I will put in x minus 3. So then I will have this is equal to x minus 3 plus 2. Okay, and then if I simplify this further, I'm going to have x minus 1, and then this is my answer. Okay, now what if I have This is just me showing you different examples of function notation just so you get used to working with them. Okay, what if I give you two functions? What if I give you f of x is equal to x squared minus 4 and g of x is equal to x plus 2. Okay, and I say to you, find me f of x times g of x. I'll ask you to find me f of x times g of x. Well, all this means is that the expression that makes up f of x should be multiplied by the expression that makes up g of x. Just multiply them together, all the expressions, right? Multiply them together. So we know that the expression that makes up f of x is x squared minus 4, right? So you're going to say x squared minus 4. Then you're going to say times the expression that makes up g of x, which is x plus 2. So x plus 2. Okay, then you multiply them together and then you solve. Easy. Okay, so let's say now I say to you, okay, cool. You just multiply things out here and then you solve. Let's say now I say to you, what is f of x minus g of x? Well, you will tell me that, okay, so f of x I know is x squared minus 4. And you know that g of x is x plus 2. Those are given to you, okay? They've been given to you. You will tell me that, okay, the expression that makes up f of x should be used with the expression that makes up g of x to find the difference. So all you do is add the negative there. Okay, so you subtract that expression, which is this down here. You subtract this expression from that expression. That's what this means. Okay. So you see, they can do a lot of different things. They can ask you to, the whole point of this thing is that the name of your function, this notation here simply tells you the name of your function and the variable that it is made up of. Okay, now they can even ask you questions like, if we give you f of x is equal to x squared minus 4, and we give you g of x, which is equal to x plus 2. Okay, so for which values of x? So for which values of x? I left out the 4. So for which values of x will f of x be greater than g of x? For which values of x will f of x be greater than g of x? Now, all that they're asking you here is, you can solve this mathematically, you can solve this graphically. I love solving it graphically, and this is why you should learn how to sketch quickly. Okay, so we've been given these expressions. And they're asking us, for which values of x will f of x be greater than g of x? All that this means is, if you were to sketch these graphs out, okay, I'm going to sketch these graphs out very quickly and very roughly. Okay, so if you were to sketch these graphs out, I know that, let's just say 1, 2, 3, 4, 5, 6, 1, 2, 3, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. If I were to sketch the first one, I know that f of x has 2 there as my x-intercepts, and it has 1, 2, 3, 4 as my y-intercept. Then it does that. Okay, and the other one is x plus 2, so it has 2 as the y-intercept. It's a straight line, it has a positive, this one here that I'm looking at now, and the x-intercept is minus 2, right? X-intercept is minus 2, so it goes through there. Just actually, let me sketch it using a different color. It should pass through these 2 points, and it's a straight line. It's a straight line. Okay, so this is, now if I were to label these graphs, this straight line here, the name of this straight line is G. Okay, and the name of this red line is F. I just sketched these graphs very quickly. Okay, you should know how to sketch these graphs. Practice sketching your straight line graphs and your parabolas. Now, they're asking me for which values of x will f of x be greater than g of x. Where's f and where's g? Here's my f. I've labeled my f. My f is in red. My g is in blue. Now, for which values of x will f of x be greater than g of x? Where on this graph is my f above my g, right? Where on this graph is my f above the g? Once you can locate that point, then you can find the corresponding x values that they're asking you to find. So you will notice that at that point and at that point, the red graph is above the blue graph. Here's the blue graph here, right? The blue graph is here. The red graph is above the blue graph. This is what this thing is telling you, right? F is above G. F, which is red, is above G, which is blue. For which x values are those points applicable? Well, it's from that point there, that x value there, and that x value there. Okay, and to find that x value, you're going to have to find the intercept, the point of intersection mathematically. Okay, I'm not going to do that in this video, but that x value there. So you've got an x value there, and you've got an x value there. This x value we know is -2. Okay, that x value we know is -2, and that x value we're going to have to find mathematically. That's all that this means. Okay, this is essentially function notation. The first letter tells you the name of the graph. The letter in brackets tells you what the graph is made up of, and the expression on the other side of the equation sign, or of the equal sign, tells you the expression that dictates the behavior of the graph. Let's do one final easy example. If you've got k of x, right? They tell you that k of x is equal to x to the power of 3 minus 2. And then they ask you to find k of 2. And they ask you, what is k of 2? All that they're telling you is that wherever you have x, you must put in a 2. So this graph is made up of 2s. It's not made up of x's anymore. It's made up of 2. So wherever you have an x, you must put in a 2. So then you're going to have, instead of an x that you have there, you're going to, in brackets, put in a 2. Okay, and then you're going to keep the rest of the information. And then you're going to solve. 2 times 2 times 2 is 8 minus 2, and then your answer is going to be 6. Okay, and then that's going to be your answer. That's all that it means. The name of your graph is k. Wherever you have a variable, you put in 2, and then you use the expression that was given to find your final answer. Okay, so this is the function notation that you use to solve these things. Okay, hopefully it made sense. They like asking such questions in metric, and hopefully it's basically just a language. It's a mathematical language. It's nothing complex. Okay, in the next video we'll continue with our functions. I will look at inverse functions. Okay, till next time. Lesson number one, lesson number one. Lesson number one, lesson number one.